Hello everyone, my name is Abdullah Abdul Hakim. I'm embedded Android and Linux engineer with experience in Android systems, kernel, and embedded software development. Welcome to the podcast series focused on problem solving, coding skills, especially for embedded systems or for already software in general. So today we will start with yeah with the array topics. Okay, let's move to this. Yeah, we will already focus on this episode on the array. Okay, so we can say it is a basic but powerful data structure used everywhere in programming. And an array is a collection of elements stored in a fixed size, ordered sequence, allowing fast access by index. And we will focus on first problem. Yes, our first problem is the product of array except self, and the goal is to create a new array where each element is each element is a product of all other element except itself. And the problem helps us to practice efficient array traversal and understanding prefix and suffix product without using division. And we will go through example and discuss. We will follow the structure approach together. Okay, and we can say at the beginning about the array. Array is a collection of elements stored in order. Each element can be accessed by its index, and the array have fixed size, and the array used to store the data efficiently. And the common operation include reading, writing, iteration, and searching, and so on. And why array are important? They are the foundation of many algorithms and the data structure. Understanding the array helps solve many coding problems and so on. So to avoid a lot of time, so let's move to the first problems about the product array. This one, okay. As you see now, this problem, okay. This is a product of array except self. We need to read the problem at the beginning before starting solving the problem or coding the problem with the interviewer. So given an integer array nums, return an array answer such that answer of I is equal to the product of all elements of num except this already nums. Okay. Yeah, the product of any prefix or suffix of num is guaranteed to be fitted in a 32-bit integer, and you must write an algorithm that runs in big of n times and without using the division operation. During solving these problems, we need to follow the structure approach. First thing, you need to understand the problem to align with the interviewers. Then you need to really to ask some clarifying questions, clarifying questions about constraints, the input, output, and so on. Then you need to really walk through on some examples, okay, to for expected behavior and to ensure you are aligned with the interviewers. Then you can already now get your assumptions and list all of edge cases, and you starting with thinking out loud with the interviewer, and you need to really to share what's inside your brain. Okay, so you can already starting with brute force as a baseline, then you can move forward to next one, optimize approach, and so on. So let me start with understanding the problem. So we have now given an integer array, return an array output such that output of I is the product of all elements in the input array except nums of I. No division allowed. Yeah, as you see now, the constraints here, you can already check the hints and so on. No division allowed. And this problem already under the array manipulation, prefix, suffix, products, and so on. Okay, and our objective here complete product of all elements except self efficiently in big of n time and big of one extra space. Okay, and then you need to already to smart some clarifying question to get any ambiguity requirement, to get the requirement to understand everything. Okay, and first thing you need to ask about, can the input array contain 0? Yeah, you can assume it now as a yes. And you need to really to ask about what is the expected output for the single element array. Yeah, okay. Yes, this is we will return 1, for example. and you need to check are negative numbers allowed or not. And yeah, every questions have why questions, okay? So you need to understand why you are asking these questions, okay? Then what is the maximum size of the array? Yeah, assume large and so on. So then you can already check all edge cases. Maybe you have single element arrays, maybe array with one or multiple zeros, maybe array with all ones, array with negative numbers, large array size of performance and so on. So this is already, you need to check it. So my intuition here is the product except self at index I equal product of all elements before I prefix multiply by product of all elements after I suffix. Okay, and we can compete prefix product from left to right, suffix products from right to left, then multiply. I think as a high level approach, we can create prefix product array, create a suffix product array, and multiply prefix suffix product for each index and optimize space and so on. This is my intuition. Okay. Okay. So the high level approach, you need to think about it and think out loud with the interviewer during the interview. Okay. So you can starting with the brute force if you get it. So for each index you can multiply all other elements. So but this cost will be big of n square time and big of one space. Okay, if you already started with implement this is, you need to know the cost of it. So this is as an example here, example one, output nums 1 2 3 4. This is the already first element will be multiply of the all element except itself. Okay, so this will multiply 2 by 3 by 4 and so on. So we will starting with brute force. Yeah, we can already skip it and discuss the optimized approach. You can already optimize approach with the already interviewer and they start to solve it by it. Okay, the optimized technique uses prefix and suffix products, as I told you, to avoid division and this is achieve big of n time. And we create an output array where each element at index I is a product of all element to the left prefix and all element to the right suffix and so on. So we do two passes, left to right fill prefix product and right to left to multiply suffix products. This approach uses big of one extra space, excluding output, and run in big of n time. Okay, so we will initialize the output array with ones and traverse from left to right, updating output of I with prefix product, and traverse from right to left, multiply output of I by suffix product. Okay, so return is the output array and so on. Yeah, I solved it before, so I hope it be easy with all of audience. So we can starting yeah get the size of the input array at the beginning. So I will create the n with nums dot size. Okay, this gets the size of input array. Then we will already initialize output array with ones. Okay, this is vector of integer called output. Yeah, this output, all of the elements will be one. Okay, and then we will already create the product accumulator. Yeah, so int prefix equal 1. This is prefix product accumulator. Then I will iterate left to right pass. Then I will set output of I to prefix product so far. So update prefix product and so on. Okay. So for int I equal 0, I less than n and plus plus I. Okay. This one I will set the output of I was prefix and prefix the prefix product, so prefix multiply equal nums of I. Okay, this is first thing. Yeah. Okay, then I will make this is for suffix product accumulator. Okay, this is int suffix equal 1. the suffix product accumulated, and then we can iterate over into I equal n minus 1 and I greater than or equal 0 and minus minus I, sorry, minus minus I for this, and then multiply output of I by suffix product and update suffix product and so on. Okay, yeah, so output phi multiply equal suffix, and a suffix here, see here, will multiply equal nums of phi. This is update suffix product, and then we will return output. Let's check our problem. Yeah, during the interview maybe you will not have the ID, so you need to check and already check your code and work through on your code with some examples on the Word documents or anything, not rather than this ID and the compilation and so on. Okay, you will not already get the editor or ID to do something like that. So yeah, for the first loop, build the prefix product for each index. Okay, and the second loop here loops multiples multiplies, sorry, suffix products to the existing prefix products in the output. This is avoid division and extra arrays, and the complexity here be big of n because we do two passes, and the space complexity big of one extra space output array not counted. Okay, this works correctly with zeros and negative numbers and so on. Okay, and if we starting to run this code, yeah, as you see now it is accepted, so we can already submit the code. You need to also to walk through on some examples, yeah, in front of the interviewers. You need to calculate complexity as we well, as we made together and so on, and yeah, and maybe there are follow-up questions during the interview and so on. This is already yeah, this is my solution until now, and after that I will be more structured than that. So I will already follow the clear structure approach, but this is first pulse. After that the next pulses will be yeah, better than that. So thank you so much, and have a good day.